Hi everyone, good afternoon. I hope you guys are having a good time with the learnings that you are gaining from these talks. I believe all of us here are working in either DevOps or SRE projects. So, what do you think makes an SRE project difficult or hard? Any ideas, any thoughts on that front? What kind of things can make SRE responsibilities hard? Like on call, yes. You might be sleeping somewhere and suddenly you get a pager duty notification. You have to get up and check that, and maybe you have to go and fix something right then and there. And some other things that I have seen in some of the projects I have been part of is that sometimes there is no run book created for the fixes that have to be done. Many times it happens that we are doing the same fixes again and again, but there is no run book created. So sometimes it happens that the senior person, whoever is the senior person by historical reasons, he has full responsibility. The new person comes into the project, he doesn't know anything, so he has to be groomed and he has to be given the knowledge. If we had run books, these things would be easier. And that's one thing. And then there is the thing of automation. I still see many projects without proper automation of the things that could be done to either fix the issues or even maybe avoid the issues itself. So this is the main stress point of my presentation today about how to automate SRE activities by using AI agents. Just a little bit about myself. My name is Manu Muraleedharan. I've been in the software industry for more than 20 years now. It's my third year as an AWS community builder, which is a community of AWS community people who are creating content and working in the community. Multiple AWS certificates I have taken, and currently I'm working as an AWS cloud architect with Serverless Guru. Coming into the topic, so we have seen how the AI has been showing that evolution through the previous maybe just 2-3 years now. So first we used to have these chatbots. We used to go into ChatGPT and we can ask questions and it tells us things. And in the beginning, if you remember, it used to say, if you ask something about a current affairs, it would say, my knowledge cutoff is only up to this date. Anything after that, I don't know. It used to say that. And you couldn't ask anything to the ChatGPT about things that are relevant to your project, your organization, your enterprise, or anything like that. And you didn't have a ChatGPT like that in the office. Now, things are changing now, right? So now we have something called the retrieval augmented generation or RAG pattern, which means that any kind of private knowledge you have, you can put that in a embedding, you can create embeddings out of that and you can put it in a vector database and you can give it to the ChatGPT or whichever AI you have. And the AI will be able to go there and get the answers that you need about what your private knowledge repository might be. So you can ask it things like, hey, AI, how many leaves can I take this quarter? Or what is the eligibility I have for doing a project party, or any kind of questions like that. Or coming into our SRE thing, you could ask questions about how can I fix this issue in the network, or what are the things I should do to figure out what is the issue in my database, or those kind of questions. And now we are coming into the new AI evolution, which is of AI agents. And this is what I would like to talk about. What's the difference between a normal AI and an AI agent? An AI agent is really an autonomous system who can take actions in behalf of you. We all know this already. So it can do, the main difference is that it can utilize tools. We have already created so many tools for doing things in our life, like we have different CLIs for doing things in Kubernetes. We have tools for doing something on the database, on the OS, and we can call different APIs and get answers from those APIs. All these are tools. And if we just take all these tools and give it to the AI and tell that this tool is for this, tool is for that, the AI will be able to call these tools and get whatever answers you need, and it will be able to do things on behalf of you. It also has the combined abilities now. Earlier it would be able to just do the search and give you the answers. Now it can reason with the knowledge that it has got, and it can execute some tools on behalf of you, which means that it has now the full range of capabilities. And it also has the memory as to what I have been talking to the user about, what things I have already done, and what things are to be done to actually complete this, to be able to satisfy the user's need. So today I would like to introduce to you Trans Agents SDK. This is an SDK for creating agents very flexibly and very easily. This has been created by AWS. With just maybe 3-4 lines, you can create your own AI agent. You just have to bring in your AI API key. Maybe if you have the ChatGPT API key, you give it that and it will be able to start acting as an AI agent. So it can run the tools, it can use any LLM models. So previously we used to have agents, or we have Cloudflare agents, OpenAI agents, which work with their own models, but this Trans SDK is such that it can use any LLM model, be it public, private, or anyone, it can use that. And it can also use memory storage. It stores the conversation history and keeps track of what has been done, what still needs to be done. So how are we going to use this? So I talked about this already, retrieval augmented generation. We take all the runbooks that we have now for fixing whatever issues that we have. We create embeddings. Embeddings are nothing but a numerical representation, and we put that into a vector store, and we give access to that vector store to the LLM model. Now we can ask the LLM model questions based on what all the runbooks that we have put in the vector database, like how do I fix this database issue? How do I fix this OS issue? It will go and look in the knowledge base, and then it will compare with your question and see which knowledge from this knowledge base I can use to answer that question, and it will be able to tell you. Then the next evolution that we talked about is AI agent. So now I have got multiple tools on the right hand side of the screen, where I have DB tool, I could have the email tool, I could have a tool for the payments, get the weather. All these are different tools that I have access to. I give all these tools to my LLM model, which is now become an AI agent, and now I can ask it any questions. So it can look at the question and see which tools I need to use to answer this question. And it will go to those tools, run those tools, get the answers from the tools, and then it will see how can I use these answers to answer my user's question, and that way it's able to complete the task. It runs this in a loop, like it gets the input and context from the user, then it will select which tool I should use. If I asked it like, hey, what's the weather in Chennai? Is it raining or is it sunny? It's going to check the weather tool, get the answer, that's a tool execution. Then it will see, does this satisfy the user's request? If yes, then it will go and give the response. Otherwise, it's going to go in a loop. What else is required? Maybe I asked it to, can you check the weather report in Chennai and book a ticket for some kind of entertainment? So if it's going to rain, maybe it's going to book a movie ticket, but maybe if it is sunny, it might be booking a different type of entertainment for me. So here I would like to introduce to you another tool called OpenSearch. This is the open source version of the Elasticsearch that we have. We use this as a distributed vector store mainly. So for using in terms of RAG or retrieval augmented generation, we need a database that can store vectors, and we are using OpenSearch for that. And all the knowledge base that we have, we can give it to the AI, convert it to vectors and put it into OpenSearch, and we can at very fast rate, we'll be able to search that. We can combine both. Now we have a great vector store and a great agent SDK. Combining both, we can create an agent that gives us what we need. So this is the architecture for the AI SRE agent. So on the left-hand side of my screen, we have a CloudWatch alarm. CloudWatch is the monitoring tool within the AWS. So it gets all the logs, metrics, traces, everything. So based on that, we can create alarms within CloudWatch, just like any other monitoring tool out there. So we have created an alarm. So maybe it's seeing that the CPU utilization is above 80%. Or maybe the load on the database is too much. So depending on that, it's going to send the alarm to the LLM model. Now this LLM model has access to multiple tools out there. So it could be an OS tool, it could be a Kubernetes tool or a database tool. And then it also has access to a Slack, that's another tool. And then it also has another tool that sends the approval message to an SRE user. So what could happen is that it looks at the alarm, sees what kind of an issue it is. It can go to the OpenSearch index and check the runbooks to see what should I do in this case. It finds out that I have to check the maybe database load. I should check the disk usage, how much disk space is remaining. I use the tools that are required to do that. Once it has that information, it can either resolve the issue if it can using the tools, or it will send a message to the Slack. If it's not sure about if it's not like more than 90% sure about the action plan that it has, it can also send an approval message to the SRE user asking for some kind of approval. So in a real world scenario, we can use this to do automated incident resolutions. Say we have a rest spike in some kind of service. That alarm goes to the AI agent. It will go to the OpenSearch, query that index, find out what steps it needs to do. It will generate a plan from that, run the tools according to that plan, and then issue will be verified, and then it can document that saying that, hey, I have seen the issue, I have done this 1, 2, 3, 4 steps, and now it is fixed, and this is what has happened. You can verify. Currently, how we are running this is we are running this with a human in the loop, because we are still getting the trust built in that AI tool. So this is a tool we are still building. So currently how it is happening is that this tool works as a tool. This whole thing works as a tool for the SRE agent. So currently there is a human in the loop who is going to check and verify that this action plan is okay, you can do it. But it still saves a lot of time for the SRE person, because they don't have to spend a lot of time going through the steps, doing the same thing they have done thousands of times again. Just, tell to the agent, okay, I'm okay with this plan, you go and do it. But tomorrow I'm sure that we'll be able to run this completely automated, and we'll be able to achieve great number of success. What can we do with this in the future? So we can obviously do AI-driven ops, automated incident resolution in all cases. Maybe in the day after tomorrow, we might see that we are using the AI agent to solve almost 90% of the incidents can be solved with that. We can do the customer support with it. We have different number of bad downstream supports might be there. Maybe our customer is a different team. Maybe our customer is the actual end user. So they might have different issues based on the issue that's happening in the system. We'll be able to support them. Security, revenue ops, FinOps, all these areas we'll be able to support it using the AI agent. I would like to just play a couple of clips here. In this demo of the rack, so we are asking a question on how to fix this network issue. It's going to search the OpenSearch index to see the runbooks and generate a response from that. So here you can see that we are using the Anthropic Cloud Sonnet 4 as the model, which is coming to us from Bedrock, which is another service within AWS. But you can also use any model that you have out there. Could be the ChatGPT, could be DeepSeek, or any other model. This is running from my own this was running from my own local machine, and it takes a little bit of time. So it took some time, but it found out all the steps that it has to do, and it gives those steps. So this is how the RAG works, and this is a demo for the agent as such. So we have the automatic SRE agent here. So we run this demo. Same thing happens when the alert comes from our monitoring solution. It checks the incident is initiated, it checks what it has to do, prepares for the diagnostic, checks the open search index for what steps it has to do. And using the tools it has and the authorization and authentication it has, it's able to run those tools. So it went through the tools and did the actions that it has to take, and it has given us a report on what has been done. When the search meets reasoning, data becomes action. That's the quote I would like to leave you with, because today we can just search about the things and find the answers, but when we can really take action on it, that's when we have reached the destination. Thank you for your time. If you have any question, I'll take them. This is my QR code for the LinkedIn, and I would be happy to connect with all of you. Thank you.
Agent will screen every incoming alert, because I'm just thinking about the scalability of this agent itself, right? Because every minute I get 100 alerts. So is there a filtering that happens before the agent starts its work, or all the alerts gets funneled into the agent?
That is a good question. It also reflects on the noise that you have in the observability system that you have. This is a decision that we have to make, like what are the types of alerts that I want to send to the AI, what are the things that I want to send to my human team. So we would, in ideal scenario, what we want to do is that everything that can be automated, we try to automate and send it to the AI agent to fix them. And we only take the other type of the next level of issues that needs the actual human to do the innovation, that should be sent to the SRE team. In my project, that's how we try to do it.
So this is more for a known error and an SOP, executed SOP.
Yeah, mostly for the run books and removing the grunt work from the SREs. Because what we have seen is that most of the time, a big number of issues are coming from a known point of the system, where we know that these things fail at this time, this is what we have to do. It can do a little bit of, what we have seen from my experience is that a huge number of incidents it can resolve on its own, and then maybe a 40% of the incidents it can analyze it and come up with a plan on what might have to be done. But currently we have put a human in the loop. Many times it is correct, the plan is right, and we ask it to execute. Even because the next thing is that if you are doing it, asking the AI to do it, that means that we are saving time for the SRE person. He can get the results much quicker by doing that. So that's also an efficiency that we can aim for.
Glad that you answered it, because I was wondering, because to execute a runbook, we don't need AI. I could do it with just simple automation. But you're saying it also tries to suggest solution for unknown issues. So how could you find it to be like? Because you still have human in the loop. So how is its accuracy?
Accuracy is improving. I would say we are about 80% now, but we are still not ready to remove the human from the loop yet. But we are very close to it.
Thank you.
Thank you.